Okay, so I want to do another problem that was asked over email. Actually, there's two of these problems to do, and they're both from the same section, 3.4.37. The directions on these problems are to use the given zero to find the remaining zeros. We'll see if we can get both of these on one video. Okay, the first problem that was asked is they give us h of x is equal to 4x to the fourth plus 7x cubed plus 34x squared plus 63x and then minus 18. They tell us that one of the zeros is a negative 3i. Okay, so what we're going to do is we're going to use this information right here. This information, they tell us that one of the zeros is a negative 3i, and we're going to use that to get an expression so that we can do some long division to find the other zeros. So if I know that negative 3i is a zero, then it would have had to have come from this position right here. It would have had to have come from some point x minus 3i equaling 0. Okay, and the other thing is the conjugate pairs theorem tells me that if negative 3i is a 0, then then positive 3i is also a 0, and that would have had to have come from x plus 3i equals 0. So if I sort of work backwards, I know that both of these are zeros, then I would know that it would have had to have come from, something like this, okay? Because I would have used the zero product rule to go to here and then solve to get these values. So really what I'm looking at is I'm saying, well, if these are zeros, then they came from this expression right here. So I'm not really concerned about the equals 0 part right now. I'm just concerned about finding what quadratic did these two zeros come from. So if I take this and FOIL it, I can find out what quadratic it came from. Okay, so the first is x squared. The outside is a positive 3xi. The inside a negative 3xi. And the last is a negative 9i squared. Okay, these two add to be 0. And I squared is a negative 1. So I can plug a negative 1 in for the I squared. And this is going to become x squared plus 9. All right, so what I just found was that these two zeros right here, negative 3i and positive 3i, had to have come from this x squared plus 9 being one of the factors of my original function here. Okay, so if I want to find the other zeros, if I know that this is x squared plus 9 is a factor, then it must divide into this evenly. Okay, so I should be able to take the x squared plus 9, do long division into this, and find what the other quadratic is, and then I can solve that. Okay, so let's do that. Let's take the x squared plus 9, and we're going to long divide it into the original function. So 4x to the fourth, 7x cubed, 34x squared, 63x, and then minus 18. Okay, so the way long division goes is we take the first term, this first term right here, the 4x to the fourth, and we divide it by the first term in our divisor. So it's going to be 4x to the fourth divided by, actually, let's see. I'm going to do this off to the side, but this is going to be in the way. So I'll do it on a scratch piece of paper. Okay, so taking first term and dividing by first term would be 4x to the fourth divided by x squared, and I'm going to see what I'm left with. If I did that division right there, I would be left with a 4x squared. Okay, so that 4x squared is going to be what goes up top. Okay, so let's see if we can get all of this on the screen. All right, that's a little better. So we have 4x to the fourth divided by x squared. So that's 4x squared, and that's going to be what goes up top. Excuse me. Okay, what's going to go on this line right here is taking the 4x squared and multiplying it through the whole x squared plus 9. So I actually have to distribute that, if you can see it. Take the 4x squared, distribute it through the x squared plus 9. So that's going to give me 4x to the fourth. And then notice it's going to give me a positive 36x squared. That's actually going to skip this cube, and I'm going to line it up with the square. Okay, so there's just nothing happening there with the cube. Okay. All right. Now you know how division is. Division is repeated subtraction. So I'm going to have to subtract. I'm actually subtracting this entire line. So when I go to do subtraction, I don't know if you'll be able to see the red here or not, but I'm going to change the sign. So this one's going to become a negative. You can kind of see the red. And this one is going to become a negative because I'm subtracting the whole quantity. Okay, so the 4 minus the 4, that's going to go away. Bring down my 7x cubed. And then I have 34 minus 36, because this now is the sign that I'm using. So 34 minus 36 is a minus 2x squared, and then bring down the rest of my problem. Okay, now we're just going to do what we did all over again. We're going to take the first term into the first term and then distribute that and subtract the whole thing and continue it until we get down to no remainder. Okay, so I'm going to take the 7x cubed, that's the first term and what's left, and divide it by the x squared over here. Oops, there. And 7x cubed divided by x squared is going to give me a 7x. So that 7x is going to go up top. And then I'm going to take just the 7x and multiply it through the x squared plus 9. Okay, when I do that, I get 7x cubed and then plus 63x. Make sure you line up like terms. Then I have to do subtraction. So I have to change the signs. They're both positive, so they go to negatives. That adds to be 0. Negative 2x squared, that adds to be 0, and then minus 18. Okay, and then we do again first term into first term. Negative 2x squared divided by x squared is going to give me a negative 2. Oops. Negative 2. That negative 2 is going to go up top. And then I'm going to take the negative 2 and distribute it through the x squared plus 9. Okay. So that's going to look like negative 2x squared minus 18. When I change the signs here, the signs are actually going to go to being positive because they're negative. So subtracting negatives ends up being positive. I get a remainder of 0. I should expect a remainder of 0. If I get a remainder of anything else, then I've made a mistake for these problems. Okay, because we know it's a given that x squared plus 9 is one of the factors. Okay, so what I can do now is find the remaining zeros by setting 4x squared plus 7x minus 2 equal to 0. Because basically, the factorization of my original problem, let me actually show that to you. The factorization of this original problem now is x squared plus 9 times the 4x squared plus 7x minus 2. Okay. All right, so let's solve that quadratic. I'm doing this quickly because I'm running out of time. They only give me 10 minutes. 4x and 2 and 2 and 1. So if this is positive and that's negative, okay, then we can set each piece to 0. So we get x equals 1/4 here, x plus 2 to 0, and x equals negative 2.